this is the last time I'm going to do this year. Sorry that I have to go through it. I'm going to try to go through it fast so it's a short video for you. This is pretty similar to what we've been doing, but there's some key words here. So going through reading this, when we're talking about the word and, which we've done before, we talk about multiplication. But now, today, instead of talking about multiplying the two probabilities together, what if we wanted A or B or both to occur? That means that we're going to have to do some addition. And I've been foreshadowing that difference between and or before. So now, taking a look at some terminology, there's things that are called mutually exclusive events, and basically they don't affect each other. One does not affect the other. And then there are some inclusive events where one would change the other one's outcome. So if you take a look here, mutually exclusive, you draw a black card, and drawing a red card are two events, but they never can occur. They're mutually exclusive. But if I draw a black card and a king, notice there are two black kings in the deck, so that would change things. So basically, these are exclusive up here. That means that they don't overlap. These are inclusive, and technically they are two different formulas, but I'm going to give you the same formula for both of them combined because it just makes life easier if I only have to know one formula instead of two. Okay, so turn in the page. It says if you have to find the probability of event A or event B or both A and B happening, we are going to write it as the probability of A or B. And again, we've been talking about those different words, and now we're using or instead of and this it looks very similar. It's the probability of A added this time to the probability of B, and then we've got to subtract off the probability that it's A and B at the same time. Now, I'm going to mention one of the last homework problems, or one of the last problems we did in the last section when we talked about the twos. Remember I circled the 1, 2 and said, hey, it's not fair to cover that or to count it twice? Well, that's why we have this last part here. Sometimes this is 0. So if they're mutually exclusive, that A and B is always the number 0. So let's take a look at the examples because that's the best way to see the differences between these. So I've got quite a few of the new kind, but I've also mixed in some old kinds so we can see how they compare and contrast. So first example, suppose card A is drawn from a standard deck. What's the probability that I get an ace or a queen? So I am talking about the probability of ace or queen. So the probability that I choose one ace is 4 out of 52 times. The probability that I pick a queen is 4 out of 52 times. Please note, I'm only picking one card here, and I want to know if that card is an ace or a queen. So you guys need to understand the difference here between the word and or. Now, if I wanted to, this is the probability that it's an ace, and this is the probability that it's a queen. And I basically need to subtract off the probability of anything that's both an ace and a queen at the same time. There are no cards that are aces and queens. So this is a 0. We would add those together, and that would give me 8 out of 52, which I can reduce down to 2 out of 13. So your calculator is going to come in handy again. Take a look at the next example. Suppose a card is drawn from a standard deck. What's the probability of drawing an ace or a red card? Okay, so probability of it being ace or red, I know is probability of an ace. Hey, I know probability of an ace is 4 out of 52 cards. Added on to the probability of it being red. That is half of the deck. So that is 26 out of 52. Notice my denominators here. Do you see how they're staying consistent? And now I need to subtract off any cards that would be both aces and red at the same time. There's the ace of hearts, the ace of diamonds, so there are 2 out of 52 that would fall in that. That would give me 28 out of 52, which would then reduce down to 7 over 13. Okay, now the you try it. Do 1 or 2, come back to the video, do 1 or 2, come back to the video, especially if you can't get your answers. So go try the you try it. Okay, so you've tried the you try it. Now, this first example is an old problem. What's the probability of pulling 2 spades? I am drawing 2 cards here. It's not 2 choices for the same card. So this is the old stuff. This is the probability of a spade times the probability of a spade. So I know that that means I had 13 out of 52 for the first draw, and now I'm left with 12 out of 52 for the, 12 out of 51 for the second card, which would simplify down to 1 over 17. If you like your combination stuff, that is the combination 13, and we're going to pick 2. That deals with the spades on the top over the combination 52 cards, choose 2 on the bottom. Okay, so that's old school problem. Now, new school, because of that word or there. I want the probability that it's going to have 2 red, or I'm going to have 2 jacks. Okay, so I need to figure out the probability of 2 red. Now, the 2 red is what we did up here. So if I have 2 red, that is going to be my 26 out of 52. And I also need a second card, which would be 25 out of 51. Now, I'm going to tell you, look at these bottoms, because now I have to go to add the probability that it's 2 jacks. And if it's 2 jacks, notice I have 4 jacks to start out with out of 52. That's a bad 5. And that's going to be times, once I have 1 jack, 3 out of 51. So notice, individually, the little ones are like we did a couple of days ago, adding into the new formula. That's not happening. So then I also need to subtract off anything that would be a red and a jack at the same time. Okay, so that means I'm subtracting off, there are 2 red jacks, the hearts and the diamonds. So subtract off 2 out of 51, that's for the first draw, and there would be 1 out of 51 for the last draw. So a little combination of both. When you do your calculator work, you should have this simplified down to 55 out of 221. Okay, on to the last page. We are almost done. Okay, so here we go. Letters, or I'm sorry, marbles. Oops, I didn't go up far enough. That's my second one. For the word glass or slower, I want to know, notice this word or in there, so I want the probability that it's from the glass, or I want it from the word slower. So probability that it's from the glass. How many different letters are there? There are 4 different letters out of 26 that are being used. Yes, I know there's some repeat in there, double S, but that means I just have 4 instead of 5. Add it on to the probability from the word slower. Then I look at how many letters I have, unique letters in there. 1, 2, 3, 4, 5, 6. I have 6 out of 26 there. And I need to subtract off anything that the word glass and slower would have in common. They have in common S, got an S, an L, got an L, and I think that's it. So that means that I'm going to be subtracting off 2 out of 26 letters because it's not fair to count all of them. So when you work that out, that should simplify down to 2 over 13. Okay, so now we got a bag of marbles. And with the bag of marbles, it's got 7 white, 5 blue. We're picking 4 marbles without replacement. So I want to know what the probability that all are white or all are blue. So probability of white or blue. Okay, so that means I'm going to have the probability of white. Probability of picking all white. That is 2 different ways to think about it. There are 7 for the first draw, and then there are 6 for the second draw, and there are 5 left for the third draw, and there are 4 left for the last draw. That's one way of looking at that. Or you could have done the combination. I had 7 choose 4. That deals with the white over the combination 12 choose 4. Okay, so that's my probability of white. Add it on to probability of blue. So I'm going to add to that. I have 5 blue marbles. So 5 out of 12 times 4 out of 11 times 3 out of 10 times 2 out of 9. Or in other words, I could add that to the combination 5 choose 4 over the combination of 12 choose 4. Remember the white over the total numbers. Okay, the last part of this, I have to subtract anything that would be both white and blue at the same time. That means I'm subtracting off 0. Do the calculator work for this, and it should come out to be 8 over 99. Okay, continuing on. How many ways are there exactly 3 white? So if I do exactly 3 white, kind of the old-fashioned way, probability of 3 white. Okay, these are the problems that some of you guys have struggled with. I have to do 7 out of 12. That's how many white originally, times 6 out of 11, times 5 out of 10. But I have to also multiply that, and I'm going to change colors for the not white part. And that would be, let's see, out of the not whites, that means I have they're blue. So I would have 5 out of 9 left. Okay. Now, here's the next part that you have to think about. This is white, this is white, this is white, this is not white. Did order matter in here? No. So you need to think about white, 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 not white. So it could be white, white, not white, white. My letters are bad to read. And so forth. So I have to look at all of these different combinations, and I need to multiply this whole thing by that. There are 4 different combinations. I should just finish this out. White, not white, white, and white. And then not white, 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 white. So you guys can see where that 4 is coming from. That's the number that a lot of you guys are forgetting about when you're doing these problems. We talked about that on the quiz yesterday. Okay, so if I were to do that on my calculator, it would give me 35 out of 99. If you like to do it the combination way, I could have the combination 7 choose 3. That's dealing with the white, times the combination 5 choose 1. This is dealing with the not white, and it's all being divided by the combination 12 choose 4. So that's how I would look at it the other way. Last one that we're going to look at has the word at least 3. That means the probability of 3 would work, and the probability of 4 whites would work. So notice we're going to do probability of 3, which we just did up here. We're going to have to do probability of 4, and there's an and in between, so we're going to have to do some addition. So for this probability of 3, we've already talked about that. From above, you can, ABOV, from above, you can see that this is just 35 out of 99. Now, to that, I'm going to add the probability of 4. So if I had exactly 4 whites on that, that means that I'm going to have, in here, I can work out the probability of 7 pick 12 times 6 pick 11 times 5 pick 10 times 4 pick 9. That's exactly 4 white. And when you do that, I believe, let's see, I should have 35 out of 99. That was the first one. Added on to 7 over 99. And now I also need to subtract that idea of the probability that it's 3 white and 4 white at the same time. Guess what? That's going to be 0. It never happens. So subtract off 0, and my final answer should be 14 over 33. Now, if you wanted to do this combination way, I would need the combination 7 choose 3 times the combination 5 choose 1 all over the combination of 12 choose 4. That's what we did up here in number 2. And that's going to be wrong sign, so let's fix it. Added on to the combination 7 choose 4. That's getting me all 4 white over the combination 12 choose 4. Okay, worksheet 7. This should be not the last one, but the second to the last one. You guys need to have this done. On Monday, we start to review, and I can answer a whole bunch of questions, but you guys need to have tried these so we can work through it. So, have a great weekend. Try to get this stuff done in class so you don't have to take it home. Bye.